Okay, so in this one, this is on page 103. This is the part of the daily lessons that we didn't get done. But I want to make sure that we go through that. The first one, you can put in these values and figure this out. So I'm not going to go over that one, but I will say this one. The radius of the sphere is increasing at a rate of 2 inches per minute. So this is talking about radius of a sphere. So I've got dr dt is 2 inches per minute. It says find the rate of change of the surface area of a sphere. So somehow I need dA dt. And radius is 6 inches. If you think about a sphere kind of looks like this. Well, it's really hard to see. And then if it's talking about increasing, it's getting bigger and bigger and bigger and bigger. So the radius is also going to be increasing. This is only for an instant. If it's at an instant, I can't put it in until after I found the derivative. It is not constant. I can't put it in the beginning. So this talks about the surface area of a sphere. The surface area of a sphere is 4 pi r squared. This is one that I would give you. The derivative of area would be dA dt. 2 times 4 is 8 pi r, my new exponent is 1, times dr dt. And now I could just substitute what I know. So dA dt I don't know. But I do know the radius at an instant, so here's where I can plug it in, is 6. dr dt, it says dr dt we said was 2 inches per minute. dA dt would be 8 times 6 times 2. So I've got 48 times 2, which is 96. And I'm just going to write the pi here. And I have to remember to put in my units. And I can see it's talking about the surface area of a sphere. That would be square, whatever unit this is, so inches squared. And we said the units would, or the unit of time stays the same, so per minute. And if you weren't sure about that, radius is in inches, and so is, this was inches per minute. Inches times inches is inches squared, divided by minutes. So I've got dA dt is 46 pi inches squared per minute. If you want to multiply 46 times pi, that's totally fine. Excuse me. Just make sure if it's your final answer. Scary, guys. You wouldn't think that this setup I have is foolproof, but there we go. Or isn't foolproof. I have this on meter sticks, so it can come above the desk. Anyway, if you multiply this out, make sure that you either round or truncate to 3 decimal places if this is your final answer. If you plan to use this later in a problem, you have to make sure that you use as many decimal places as possible, or I guess extend to as many places as possible. The next one, still a spherical balloon. So spherical, think of one of like those balloons that you punch back and forth, you go like, yeah. A spherical balloon is expanding at a rate of 60 pi cubic inches per second. So 60 pi cubic inches per second. Cubic inches is talking about volume. So this would be dV dt is 60 pi inches cubed per second. How fast is the surface area of the balloon? Ooh, crazy. So it's asking dA dt when the radius of the balloon is 4 inches. So that's for a moment. So it's giving me volume, asking about area. Don't get overwhelmed. Just go one step at a time. So volume I began with. So volume is 4/3 pi r cubed. This is another one that I would give you. The derivative is 3 times 4/3. You get 4 pi r. 3 minus 1 is 2. But you can't forget to do the derivative of r, which would be dr dt. This was asking about surface area. So area is 4 pi r squared dr dt, while surface area is. What am I talking about? I got ahead of myself. Area is 4 pi r squared. So the derivative would be 8 pi r dr dt. So over here, I'm going to plug in what I know. I'm going to get 60 pi for dV dt. Radius was 4 at that instant, so I can put that in now. And you can see I can solve for dr dt. And then over here, in order to get dA dt, I just use my answer. So if I solve, I'm going to divide both sides. 4 squared would be 16 times 4 I would get 64 pi. I could reduce, but I don't actually have to. So if you said, oh, well, I know this is 15th, 16ths, do that. If you want to keep it as 60 over 64, do that. And I'm going to come over here and say dr dt, or dA dt. It's a pi. The radius is still 4. dr dt, I can use 15 over 16 or 60 over 64. And if I say 8 times 4 is 32, divided by 16, I get 2, times 15, I get 30, times pi, I get 30 pi, but you can't forget the units. So this would be cubic inches was the volume, so this is going to be inches squared since we're talking about area. And it said per second up here, I'm still going to use per second down here. And if you were confused, r, the radius, would be in inches. This would be in inches per second. Inches times inches per second would be inches squared divided by seconds. So I'm hoping this is helpful. Starting at page 104, there are a bunch of videos online, but there you go.